seems maybe we may need some more time because it's it's too short. It's just one day, but it seems that this one has been inhibited. Now, there's a very little bit of growth here, very little bit of growth. We don't know, maybe the people killed the bacteria with the heat, but it also seems that these are inhibited, I would say maybe. These one are actinomycetes. They grew very well here. They seem not to be inhibited. Maybe this one produces an antibiotic. Maybe this one also produces it, and they are resistant to this one. But at least some of the bacteria here may be inhibited. Okay? Now here we see just the opposite. You see the copriotrophs, they have grown very, very well, and they are not inhibited. Now the actinomycetes have not grown. We don't know why. Maybe it's too short a time. Maybe if we put that in the incubator for another 24 hours, we will see that they're growing. So we cannot say. Maybe technical, maybe they forgot. You know, you always have. Yeah, and here it's something in between. Yeah, this one is a bit strange. This one you see is also growing, also seems to be inhibited. Maybe it's because it's a slow grower, so you also have to let it more time to see, but maybe it's inhibited, maybe this one as well. But you see that with this very simple technique, if you do it right, and if you look long enough, you can discover interactions. You can discover bacteria which can potentially inhibit others. Now we just took randomly, right? But let's say that you have a bacterium, a pathogen, and you want to find a bacterium which produces antibiotic against this pathogen. So you just strike your pathogen, you put your isolates, and you see which one will inhibit the pathogen, right? Or which one is resistant to one antibiotic producer that you know. So you can really easily do this kind of things. Okay, and isolate bacteria this way. Okay? Now here it's going to be more complicated, I think. Okay, wow. Basically, I don't. Do we have the chart of the? Yeah. Basically, I think that if you have everything like this, it means there's no interaction. You know, they're growing nicely one next to the other. Okay, you have to be careful. Okay, now when you have one like this, I don't remember what we had, but these are probably the controls. So I have to see the chart. Thank you.
The printing doesn't print the gray circles, so you have to imagine that.
So copriotrophs. Do you remember?
I can explain.
Yes.
This one is copriotrophs.
This one.
The blue point is copriotrophs. Yeah.
Yes.
And the blue point have circle around is copriotrop E, copriotrop A, and copriotrop B, and the red point is
actinomycetes. Yeah. Okay. So you see, for instance, here, the copriotrophs, they seem not to have many interactions together, right? Because they all grew nicely. Now, what is that? This is the copiotroph in actinomycete, copiotroph in actinomycete, copiotroph in actinomycete. Well, again, maybe the actinomycete didn't grow here because it's not enough time. Maybe the copiotroph grows very, very fast and just, depletes the nutrients around or produces some substance, because there are so many of them, that the actinomycete cannot grow. Because here you have the actinomycetes, some of them grew. So also when you do, this is very just to show, but when you do this kind of experiments, these kind of things, you have to take more space, etc., and time. You can easily, what I want to point out is, by using plates, just like your colleague did with the fungi, you can find a lot of different types of interactions. So if you had, for instance, here one colony, if it's growing alone, it has a certain size, and if near it there's another colony and it's growing more faster, let's say, and bigger, then you can think that they may be exchanging something that makes them grow better. If you see that it's smaller, maybe there's antabiosis. If you see nothing, maybe there's no interaction. Okay? Or antabiosis or competition or whatsoever. So you can learn a lot just by plating one bacterium near another bacterium. Sometimes I have a colleague, she looks at the way bacteria move. So she has plates, very beautiful. So she cuts the plate in two. So there's no contact between the two halves. And she plates one bacterium on one plate, and she places another bacterium on the other plate. She knows that the bacterium here produces some volatile compound, and she wanted to see what this volatile is doing. And she found out that this volatile induces the other bacterium to grow faster, or induces the bacterium to start moving by gliding. So, with this type of plates, you can really learn a lot of things. Okay? Now, questions? This type of plates, or this type of plates, or any other